Hello, everybody. How are you all doing out there? I'm just going to move the chat around ever so slightly. There we go. That's nice. And yes, welcome. And hello and welcome. It's a Sunday afternoon. It's 6 p.m. It's the approximate part of the week where, as a kid, I would have come back from summer long and any of you grew up with parents who used to insist you went for long walks in the country on a Sunday, and they'd sort of be like, "Come on, we have to go out of the house. We have to have a nice, good, healthy walk in the countryside." And on the way back, if you're very lucky, we'll get fish and chips. And so you'd get home at sort of 5, 6 o'clock on a Sunday night and eat fish and chips and watch. It's probably the Chronicles of Narnia or something, which would have been on TV in Britain in around this time on a Sunday evening. So yeah, that's me broadcasting in the Sunday evening. Just got home from a long walk, and you're eating fish and chips in front of the TV slot. Except it's not the Chronicles of Narnia, featuring the BBC who blew half their budget on a lion suit. It's me, hello, and we're doing Advent of Code, this year's absolute must see. It's better than Game of Thrones, and I absolutely promise you that we're not going to get as far as Advent of Code Season 8 and then just go, plot, who cares? So, welcome. Right. So, we had a lot of fun and games. Yesterday, when, for reasons I still don't entirely understand, I decided to solve Advent of Code using Amstrad logo. And last night I tweaked the video recording of that a little bit. So if any of you missed that, it was a lot of fun. It was the fun part. The way that we did it was to take the input program from Advent of Code and run that through a text transformation that turned it into a logo program. I had to write a couple of little functions to do like north, south, east, west, and then to replay the whole thing. Was using an emulator called WinApe, which has a feature called auto typing, so you can basically be like play this script as if a human operator was typing it in really, really quickly. And it took a little bit of balancing to get to the point where if it was going too fast, then it would literally overflow the virtual keyboard buffers and instructions would get lost. But if we slowed it down too much, it was going to take a long, long time to run. And so we got to a point where it's like, I think this is probably going to work, but while it's running, let's have a look at doing this in Excel instead. Just as a sort of, a stopgap measure. Fortunately, it completed and yielded the correct answer in Amstrad logo before we had to deliver a working implementation in Microsoft Excel. But I've had a little look at, and the video for that is up on YouTube now, just the Amstrad logo bit. So the video for that is up on YouTube now, so you can go and check that out. But we're going to have a look today at day 13. So our brief for day 13, shuttle search. Hello, Chris. I see you're commenting on YouTube again. Has Twitch become recalcitrant and uncooperative once more? So, now sometimes when you look at Advent of Code, you're like, I'm pretty sure I know exactly what they're getting at with all of this here. Certainly for part 1. Part 2 often contains some surprises. Have any of you ever read a book by Neil Stevenson called The Diamond Age? This it's a wonderful sort of Victorian steampunk nano-engineering fantasy set in the future. And you realize at some point when you're reading that book, you're like, he's teaching us about universal Turing machines. Chris, your survey is important to them. Please be sure to fill it out, and it will be full of statements like, support helped me resolve my issue, strongly disagree, disagree, neutral, agree, strongly agree, and it will get mashed into a giant sort of spreadsheet soup with all of the other surveys, and some middle manager somewhere in the outsourced division who does Twitch support is going to get or not get their quarterly bonus based on whether it hits his or her KPI targets for that or not. They're not actually going to fix anything. That's not what we do, not in technology. Anyway, let's have a look at day 13. So I think this is going to be a modular arithmetic-y typey question. Your ferry can make it safely to a nearby port, but you won't get much further. When you call to book another ship, you discover that no ships embark from that port to your vacation island. You'll need to get from the port to the nearest airport. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Why has seaport got a space in it, but airport doesn't? And this is inconsistent, this. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that remembers the number of minutes since some fixed reference point in the past. We have ourselves an epoch, my friends. That's what we got here. At timestamp 0, every bus simultaneously departed, and after that, each bus travels to the airport, then various other locations, and finally returns to repeat its journey forever. The time this loop takes a particular bus is also its ID number. The bus with ID 5 departs at 05, 10, 15, okay, 11 is 11, 22, 33, and so on. Spidey sense is tingling, because what do we know about 5 and 11, friends? What makes those two numbers special? They have something in common. When you figure it out, stick it in the chat. Your notes, your puzzle input, consist of 2 lines. The first line is your estimate of the earliest timestamp you could depart. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. That's going to come up in part 2, I suspect. To save time, once you arrive, all the inputs have that property. So I was glancing down, and down here we got 7, we got 13, we got 59, we got 31, we got 19. So yeah, they're prime numbers. And I'm guessing that this is going to be something that alludes to the factors of prime factorization, and perhaps even Euler's totient function, a great favorite of... Do you know, Chris just said in the chat, Seaport to Airport lyrics from one of my favorite tracks as it happened. There's a line in West End Girls by Pet Shop Boys that is from Lake Geneva to the Finland station. And it took me, I actually have been to Lake Geneva and the Finland station, which is Finlandskia in St. Petersburg in Russia, and it took me 6.5 years from first visiting Lake Geneva to go to the Finland station. And when I got there, I took a selfie and put it on the internet, like, yay, made it, Lake Geneva to the Finland station. Apparently it's the journey that Lenin took when he went back to lead the Russian Revolution. So what it's doing in a Pet Shop Boys song, I don't know. Let's go back to Advent of Code after a little lyrical deviation. For example, suppose you have the following notes. Blah. The earliest timestamp you could depart is 9:39, and the bus IDs are 7:13. Yep. So, okay, so that line, that's our 9:39. So basically, we are looking for what is the next bus that we could get. It doesn't depart, so 9:44 minus 9:39 equals 5. Interesting. At this point, they crack their abstraction and they say minutes. Because previously it says timestamps 05:00:00:00. I think that's the first time that they admit that it is actually minutes. Anyway, so multiplying the bus ID by the number of minutes you'd need to wait gives 295. So we need to know the ID of the earliest bus multiplied by how long we're going to have to wait for it. Now, I think part 1 of this might yield to some very, depending how big the input is. Is that it? Ah, that's nothing. All right, so the 101,000 minutes. Just out of curiosity, in days. 705. So the epoch was just under 2 years ago is when this bus thing started running, if that number there is the earliest number of minutes timestamp that we're going to be able to catch a bus. Now, I think that yesterday we took a little dalliance with Excel, but it was inconclusive. Based on a timestamp measures the number of minutes. No, Louise is right. Minutes was in there earlier. The input is quite big. Now, I'm gonna see. No, I do not want that. I do not want that. Okay, that's fine. If I paste that in there, I want to paste... what's the XLE thing that I need to do to... Actually, what I'm going to do is I'm going to open a... Yeah, TextPad will work for this. TextPad's editor I used to use years ago when I wrote HTML by hand before I used any IDs or anything, because I didn't have like any MVP or free licenses or anything, and I worked for a company that had no budget, so we got very, very good at using cheap text editors to make money. Yeah, for that reason I still reach for TextPad when I just need to crank something out in a hurry. There we go. Crank that out, paste that back in there. So what we are interested in is what is the earliest one of these Yes, TextPad was the Notepad++ of its day, and it's got a lot of really cool features, actually. I like TextPad a lot. I found it very, very useful for a lot of things over a lot of years. So what we are looking for here is, first of all, that number there has got mangled. Now, what I'm interested in is there's a modular arithmetic thing going on here, because for every one of these iterations, I think my hunch here, let me just check that my input fits. I'm going to make that a tiny little bit narrower. There we go. And I'm going to make column 1 a little wider, wider still. Thank you very much. So my hunch is that if we take that number there, so I want to put in here equals modulus, the number is gonna be the big number here. So $A, $1 means always A, always 1. Don't update this. You remember yesterday we had the ship and the waypoint, and if you move the ship, you move the waypoint as well. Cell references in Excel normally do that. If you copy and paste them across a grid, they will update so that they are always relative to where you paste them. If you want a cell reference that doesn't move, you put $A, $1, and it means wherever you paste it, it always points to A1. So I want to plug in that and that. Is that going to work? All right. So that there means 1015292 div 19 is going to give us highlight all columns and double click where you drag to change column size, and it'll auto size them. Nope, it only does the one I'm looking at, unless I'm doing something wrong. Ah, no, there we go. Cool. Thank you, Louise. That makes life much nicer. So I've got a so that one there. So I'm going to grab that. I'm going to copy that right across here. There we go. It's going to give us a bunch of numbers. Going to give us a lot of 8s. Why is it giving us a lot of 8s? Because I'm stupid. Because that there is the number 19. It is not a cell reference. Yeah. So that one needs to be that mod A2. That's fine. But now if I drop that across the rest of the row here. Hey, Jodo, how you doing? Jodo, Hodo, Yodo? The letter J is one of those ones that doesn't work on the internet because you have no idea where it came from, so you have no idea how to pronounce it. Welcome, nice to see you. So there we go. Let's do it again. Select everything. Oh, that's nice. Now I don't care about these hash values. Those are just crunchy. Those don't matter at all. What I'm interested in is these ones. So now this modular arithmetic number, Jodo, welcome. That tells us how many minutes we missed that bus by. That's my understanding of what that means. So if we missed a bus, the bus comes every 19 minutes. If we missed it by 8 minutes, it means that the next one is going to be here in that number minus that number minutes. So that's, no, equals that number minus that number minutes. So that's how long it is until the next one of those buses. We got a whole bunch of noise in here that doesn't matter, but I can paste all those all the way across to the end of my input. Now, I'm not sure what the significance of these X's is. I have a horrible feeling it's going to become very important very quickly. But I'm going to chop them out of my spreadsheet for now, just because the noise is getting in the way and making it very difficult to see what's going on. So I'm going to scrub that, I'm going to scrub that, I'm going to scrub that, I'm going to scrub that. That's fine. That one can go. That one can go, and those can all go as well. So that's the number of minutes until each bus is coming along. My sweet spot here appears to be a number 5. The number 5 multiplied by 643 equals, so that one equals that multiplied by that. 3215. If my hunch is correct, 3215 is my solution to part 1. Boom! There we go. 15 minutes, Microsoft Excel. Who needs programmers anyway? We just do it all with spreadsheets, and only occasionally will we accidentally lose track of 16,000 people who died, or some such thing. All right. That's part one. I have a sneaky suspicion things are about to get a little more difficult. One gold star closer. Continue to part two. So the shuttle company, one gold coin for anyone who can find the earliest timestamp such that the first bus ID departs at that time, and each subsequent listed bus ID departs at that subsequent minute. The first line in your input is no longer relevant. For example, suppose you have the same list of bus IDs, 713, blah blah, 59, X, 31, 19. An X means there are no constraints. This means that you are looking for the earliest timestamp T such that bus ID 7 departs at T. Bus ID 13 departs at 1 minute after timestamp T. There are no requirements on departures at 2 or 3 minutes after timestamp T. Bus ID 59 is 4 minutes. Whew. There are no requirements or restrictions or departures at 5 minutes after timestamp T. 31 6 minutes, 19 7 minutes. The only bus departures that matter are the listed bus IDs at their specific offsets. Those bus IDs can I'm going to read this to the end. Then I'm going to start at the beginning and I'm going to read it to the end again. So right. So let's right. And X means there are no constraints. You're looking for the earliest timestamp T. Shuttle companies. Bus ID 7 departs at timestamp T. 13 defines. Yep. Essentially find the timestamp for which each bus departs at that time, plus its position in the zero indexed list. Okay, so I'm looking for some timestamp T such that, let me put this in a different text editor that will allow me to embiggen the fontitude. There we go. So I got a bunch of timestamps that looks like that, and I want to replace that with that. Replace all. There we go. That's no. That is fine. Regular expressions on by default. Caps lock off by default. So I am looking for some timestamp T where 7 is, so these are actual index positions here. That is going to be T. That is going to be T plus 1. That is going to be T plus 2. That is going to be T plus 3. That is going to be T plus 4. That is going to be T plus 5. That is going to be T plus 6. And that is going to be T plus 7. I think. Is that... so that would then be T plus 0, so that's all right. 7, 13, whatever, 59, whatever, 31, 19. So, so effectively what we're looking at is here as a constraint that says T is such that T modulo 7 equals 0, T modulo 13 equals 1, T mod 59 equals 4. Yeah. T mod 31 equals 6, and T mod 19 equals 7. That should be 7, not Y. This doesn't look that difficult. Yeah, all right. I'm not sure how you do it in Excel, but I'm pretty sure. All right, so first thing I'm going to do is just to, I think there might be a very interesting, sort of slightly degenerate case that I can do easily in .NET. So let me just fire up Visual Studio. And new project. So there are three things. Either it's easy, or it's simple, but the runtime is going to be astronomically complicated, and so it's going to need some optimization. Or I've missed something, which is entirely possible. But let's have a look. So .NET Core console application, that's fine. It is day 13 of Advent of Code. Put that in D. Projects, GitHub, Advent of Code 2020. Yeah, that should be fine. Day 13, solution we'll call day 13. That should be fine. All right. Well, it was simple, and then you said that out loud. So you haven't missed anything. One of the other options certainly try. I'm thinking a degenerate runtime. I'm thinking something that is just gonna be, unbelievably gnarly. So, right, the first optimization. Let me grab my input here. Now today's input, it wasn't actually very big, was it? So there's the input for that thing. First line no longer matters. Plug that in over here. I don't know if you noticed that, the lights in here just flickered. If I suddenly evaporate, it means there was a problem with the electricity. We have only had a handful of power cuts here. It does say the timestamp will be very large, larger than that. Yeah, not a big deal, really. So I got a couple of ideas about how we can crunch this into something particularly exciting. So what I'm gonna do here is I am gonna grab that input. I'm gonna drop that in there. I'm gonna do a search and replace, and I'm gonna replace X with 0. Just on that line. Okay. Oh, no, not just on that line. Everywhere. No, just on that line. Come on. Come on. Come on. Match whole word, regular expression, match case. Where is the... that's... selection. Thank you very much. Replace the X's with zeros. There's that. Okay. So at this point, I can say that needs to be inside my class. Const. Now I'm gonna do. That. So basically, I've crunched that lot together and put that into a huge, massive array of things, many of which are 0. Constant input equals that lot. Why is that complaining? Constant. It needs to be a new thing, doesn't it? And it needs to be a new array. So that plugs in on there. That's nice. That bracket can come out. Let me make that a little bigger and drop the toolbox out that we don't need. That can be static read-only. Okay, cool, fine, right. The answer will be very large. This is not a problem. So, what I want to do is I'm going to say the things equals... So I got a bunch of indexes there, and for each one of those, what I need to do is crunch the set of inputs now. Okay, first I wanna just manually look something up. I want to know the index of the largest element. Now I think there's an optimization we can jump straight to here, which is that all of the numbers we are interested in have a particular property, which is that they are gonna be so whatever index that is there, they will be that index modulo 643, which I think means instead of searching 0, 1, 2, 3, 4, 5, we can search all the multiples of 643 all the way up, which will slash our problem space by 2 orders of magnitude. So what I want to do here is I want to look for the biggest number that we've got in there. So var max equals input.max. What's the biggest thing we've got in there? Now these are also unique. So var max, so var index of max equals input.index or input.find, input.search. What the hell is the thing I'm looking for? How do I not know this? Weird. .NET array index of element. It's probably either search or find. It's array.index of, which I'm pretty sure is what I had started typing. Array.index of. Do I need a something? That's fine. Why is that complaining? No overload takes 0, it takes 1 arguments. Yeah. Oh, it's a static method on array, isn't it? Ah. I love the way they do that sometimes, but not all the time. There we go. That's fine. Because that's old school .NET. That's like from .NET 1.0 when we didn't have extension methods yet, and static methods were considered cool and shiny by everybody. So I've got the input and I've got the index of max. So what I'm basically doing here is I'm gonna say so we can define a predicate here, and this predicate is gonna be something like var satisfies constraint equals, and it's gonna take some integer I, and that input I is gonna map to input dot. So for every input, it needs to satisfy the constraint that either the input dot all. Hang on. So we got input and thing. This is going to be t. All right. This is the timestamp we're checking. Int t goes to input dot all. So either. Now, is there an all method here that takes a predicate which allows me to specify? No, I want the index as well. That's what makes things a tiny bit interesting. One of my favorite things ever in .NET, talking about extension methods in the chat here, is a extension method that uses reflection to turn any .NET object instance into a dynamically typed object with the same names and property values so that you can bolt stuff onto it. It's something I use in my workshops when I'm turning strongly typed business objects into dynamic objects so you can bolt hypermedia extensions onto them and throw them out onto the internet where everything's going to be fine. So we are going to say satisfies constraint t equals input dot all, and for that all we need to say input I goes to, so if I equals 0, return true. We need the indices of all those things, though. That's the thing that I'm finding a little bit inefficient here. Is let me just have a look at .NET link all include index. How to get index? Because link mainly works with IEnumerables, and the whole point about IEnumerables is that they don't necessarily have an order. They don't necessarily have an index, so we can plug some stuff in there. Select VI, that might work. So let's take a look at the code we got baked in here. So what I want to basically do is say that for int t equals right, let's get rid of that because it's not helping. It's getting in the way, and my brain is struggling to cope with it all. So bool, so static bool satisfy or solves part 2. That's what it does. Let's face it. Int x. X is t. T is the timestamp. TS. Int TS for the timestamp. So we then want to say input.select var bools equals input.select. Now at this point I think I can pass in the so this is going to be the bus ID and the index. Those are the two numbers that we got here, right? And so if bus ID equals 0, return true. Those don't matter. 0 means no constraint. 0 means absolutely fine. Otherwise, we want to return. So that's, let me have a look at that sketch we had here in our arithmetic in whatever text editor we were using. So modulus, so timestamp modulo ID equals index. Return timestamp modulo ID equals index. And then we want to return bools.all, because if bools.every single element of that is true, it means that this timestamp satisfies all of the predicates declared by that set of inputs. So we can simplify this even further. I can return input.select.all b goes to b. That's fine. That comes out. We don't need that. What is that complaining about? Static. No, that's fine. That's fine. That's fine. That's fine. That's fine. And stick another one of those on there. That should do it. Okay. So now comes the fun part, because we need to search a very, very wide set of numbers, right? So what I'm going to do is I'm going to say in here, are there any instances where the index is greater than the element value? Yes, there are. That's interesting. Yeah, so we got a scenario here. And where's my? There it is. That's cheeky, because that didn't come up in the original one. So my actual set of inputs that I got here, let me bung that in there. Join that onto a single line, replace the comma with a tab. Okay, that's fine. Drop that into Excel and select the whole sheet. Double digit on that, right click, insert, and then this is going to be 0, 1, 2. Grab that lot, scrub that all the way across, and then in here I just want to say this is gonna be, so that one there minus that one there. That's fine. Scrub that, copy that across here, use an Excel to just kind of get a sense of the shape of the thing, and then conditional formatting, color scales, boom, that'll do. So what I'm interested in is any numbers in here which are, so that's fine, that's 19, that's 32, that's 724. Actually, I don't want that kind of conditional formatting. I want to clear rules from entire sheet. I want conditional formatting, new rule that says if the value is based on values, format scale, that's fine. What am I looking for here? It's no, that's not going to help. What I want is anything in here where that's not 0, but that's still negative. And yes, we are going to have one. It should cope with it. I don't think it's going to crash the arithmetic, but so let's just have a look. I think it might. I'm just concerned whether this is going to mess up the interpretation of the puzzle. So let's say I had another row on my input here. So I got 7, 13, 59, 31, 19. Let's say I had 5. So, and that would then be t plus 8, which would mean I need something where t modulo 5 was equal to 8, but any number modulo 5 is never going to equal 8, right? Because t mod 5 is going to be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So I need to take the index modulus as well, because that one there means that this bus number 5, add to t before taking the modulus or subtract. So yeah, Chris, I think you're on the right track there. So if that bus needs to arrive after 8 minutes, it means that bus actually needs to arrive after 3 minutes, so that the next one after that will be 8 minutes, which means I need something where it is that modulo 5. So that one equals that mod that. Yeah, so okay, we are that's looking good. That equals that modulus that. So in most cases, if the bus ID is smaller than the index, this will have no effect. It'll just yield the index. If the bus ID is bigger than the index, we'll get the next bus or the bus after that, because of the arithmetics of it. So I'm just going to throw in a couple of inputs in this thing first of all, and give us a little bit. We could just YOLO the thing, like run it with a massive set of inputs and see if we get a correct answer fall out the back. Or we could try and break it down into little pieces and understand the behavior of the algorithm. I'm going to YOLO it first, because if that works, then we win. So var I equals max. I highly recommend hooking up all the test inputs with their correct values. What do you mean hooking up the test inputs with their correct values? Not entirely sure what that means. Let me run this, see what happens, because I'm curious. And I'm aware it might be a bad idea, but it doesn't matter. So, while true, yeah, run forever. We don't care. If solves part 2 I, console.writeLine. Actually, no, we're going to console.writeLine I in every single case. They've given us a lower bound, so there's the thing. I don't trust that. Testing on a smaller provider. Oh, yeah, test inputs with the correct values. Yeah, but where's the fun in that? Alright, boom. Just because you asked nicely, you understand. Private static read only end inputs equals new 7 13 0 0 59 0 31 19. Boom. Var I equals max. So we're going to start with 59 in this instance. And we don't need. Why did I need index of max? Why was that important? Probably wasn't. Maybe it'll come back. Console.writeLine. Winner, winner, chicken dinner. And console.read key false. Otherwise, I plus equals max. Boom. YOLO. That's interesting. Yeah, so you're not care about value plus index. So you're going to advance the timestamp by max each time. Yeah, that's what I'm doing though. I plus equals max. That's what we're looking for. So let's actually say that's TS. I've missed a step. Something in my reasoning has gone wonky here. So the max there is gonna be, that's fine. Let me just check what the input solution is looking for. Same list of bus IDs, that's fine. Okay, so we're looking for 168.106.8781 in this example. So let me just run that one through. 3, 4, 5, 6, 7, 8. That's skipped way past it. Of course, yes. Max minus index of max, because we need to compensate for the modularity of the base case there. See what we get. Has that done it, or has that skipped straight past it? We'll know in a second. That didn't work. Right, boom. Okay, so we're expecting 106.8781, correct? So, what is TS modulo 0? Now, so if any of the timestamps in there, if the bus ID is 0 for any of the input things, we just return true from that predicate, so we don't do any arithmetic. And we're looking for anything where all of those cases are true. So yeah, they're being stripped out. We're just keeping them to preserve the indexes. So what I'm interested in looking at here is... So I'm just going to throw in here a little bit of console. Actually, console.writeline. No, I'm just going to stick in a debugger, actually. Boom, there's that. Run that. So what do we got? In this instance, we are testing. Our timestamp is 55. Hint on what could be used for big numbers that's coming with your actual input. All bus IDs are prime. Yep. Yeah. And yeah. I'm sure I'll work out in a minute why that is enlightening and profound. Bus ID 7, so that's 7 equals 0, so that's fine. No, next cycle around, bus ID is... Why is bus ID always 7? $350 input.select bus ID should be that if bus ID 0 return true. Let me iterate on to the next one. Right, give me a second here. Let me split this out. I'm trying to be too clever, trying to do too much in one line. Var checks equals... That's alright. I'm not relying on help too much. It's nice having folks watching in, and occasionally I get banging my head against the wall stuck. But generally, it's just nice to have folks watching. Return checks.all. So I'm going to stick a breakpoint on there. I'm going to take that off there. I'm going to run that. So first time around, checks as a system.enumerable. Yep, expand that. False, false, true, true, false, true, false, false, true. So timestamp there is 55. Let me just check one thing a second. I'm just going to see, it's possible that my iterations are wonky, but my arithmetic is good. And since this test case should yield fairly quickly, because we're expecting 106.781, I'm going to punch in that 106.8, and I'm just going to see what I get at the edge of this, see if the arithmetic is working. So scrub that, jump back in, run that. 106.8, no, okay, so the, yep. TS plus index, yeah, hang on. TS plus index? Why should TS plus index mod bus ID be 0? So we got there, we need T mod 5 equals 8, but 8 mod 5 equals 3. t mod 5 equals 3. Is that mathematically equivalent to saying t plus 8 modulo 5 equals 0? I think they are equivalent. Yeah, if we add, yeah, the test should be valid. TS mod bus ID equals index mod bus ID is the same as saying TS plus index mod bus ID equal to 0. Let me just verify that because I'm curious. So I'm going to say var modulo 1 equals TS mod bus ID equals index mod bus ID, and var mod 2 equals TS plus index all mod bus ID equal to 0. And I'm just going to console.log mod 1 console.writeline. Thank you very much, internet. Mod 1 plus mod 2. See what we get out of that. Hey, Hoppy, thank you. Thank you for sharing my thought process. Well, what else am I going to do with it? Otherwise, it just sits running round and round in its little cage. So if any numbers in there, let me just do a thing in here which says if mod 1 not equals mod 2, throw new exception. Bad maths. Right, boom, run that and see what we get out of that. We got bad maths immediately. Fascinating. Okay, so the two things are not in fact equivalent. So bus ID on 7 and index of 0. 106800 mod 7 equals 0 mod 7. Mod 1 equals false. And mod 2 gives us a different result. Fascinating. Okay. So let me just work that through. So yeah, we said there, what was our input scenario there? So we want to know A plus B. So the maths here that I'm curious about is A plus B. So A mod B equals C mod B. Does it hold from that A plus B all modulo A plus C all modulo B equals 0? So timestamp mod bus ID equals index mod bus ID, and timestamp plus index modulo bus ID equals 0. I don't think you actually saw a difference. Oh, yeah. Sorry. No, we still got a bang. That one blew up. It took a little while. That one got down here, and then it exploded. And it exploded when we got to bus ID 13 index 1. Did that throw an exception, or did it just get to the end? Let me run that again. It did throw an exception. Bad maths. Okay, so what's the exception thing we actually got to there? I want to know in that instance, let me look at the watches here, or the locals rather. Bus ID is 13 index, and timestamp is, let me start that at something nice and small and sensible again, because it makes the maths easier to reason about. Exception blown up immediately. Our watches here say, there's our quick watch window. So what do we got? Nope, none of that is interesting. Locals. Bus ID is 13, index is 1, timestamp is 14. Our arithmetic over here, we are saying timestamp modulo index equals timestamp over ID mod ID equals index mod ID. Now our timestamp in this instance is 14, modulo our bus ID is 13, equals our index is 1, bus ID is still 13. So 14 mod 13 equals 1 mod 13 equals, now 14 mod 13 is 1, so that holds. That one there is mod 1, and then timestamp plus index all mod bus ID. Timestamp is 14 plus 1. Yeah, they are, no, you're right, they are not equivalent. So which one is correct? I just want to work this through for myself so that I understand it. So let's take our example here of the bus ID 5 that is in position number 8. 14 mod 13 equals 1. Now that bus, to satisfy position number 8, that needs to come in a bus that arrives every 5 minutes has to arrive on the 8th minute, so it needs to come in on the 3rd minute and on the 8th minute, which means the modulus there needs to be 3. So timestamp mod ID goes in timestamp mod ID. But so that equal to 0, and 14 plus 1 in this case is going to be 15, modulo 13 is going to be 2, so it doesn't hold. That's false. Equals 1, that's true. So I think, yeah, I think that's the predicate or the condition that we need to satisfy for this one to be true. So let me scrub that. Let me scrub that. Bus ID zeros are always true. There is no constraint to satisfy on those. We are still looking for 10,06871. So 106,870. This should yield a solution within 80 iterations. Boom. Winner, winner, chicken dinner. All right. The math is working. So we got a valid solution that works on our test inputs. Let me now see if we get the same thing if we start that timestamp at max minus index of max. So I'm interested here in seeing the runtime as well. It might be absolutely horrific. It might not. I'm going to take that line there out because not running I/O will make the whole thing run faster. And see how long this takes to get to that. Show you something fun we can do. var sw equals new stopwatch in system.diagnostics. Yes, please. Sw.start. Tick, 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 tick. Console. If solves part 2, that sw.stop. Console.writeLine. Solution found in, and we'll do a what's the string interpolation in .NET? sw.elapsed milliseconds there. How long that actually took. There we go. Boom, run it. What do we got? Solution found in 4 milliseconds. That is appropriately fast for that set of inputs. Let's try it on something real. Just out of interest, actually, before we do that, I'm going to see how much it slows it down doing the console write line. Now, this is very, very anecdotal science. It's not real. 3, 4, 7. Okay, so the difference by doing a console.write line in each loop is a factor of 1,000. It takes 4 milliseconds to solve it, and it takes 4 seconds to solve it if we're printing out results each time. YouTube comments are being fed through. I can see Paul Anderson saying you mixed equals and not equals too. I don't think we saw a difference. That was 6 minutes ago. Um, so, and I can see Hopi saying utilized you in a video recently. I appreciate your openness. Um, I think Chris is just not allowed on the internet. I don't see any comments from Chris on YouTube, and Twitch doesn't like him commenting. Chris, what did you do? No, I'm not seeing any comments from the last comment I can see from Chris is 1840 saying you'll need to offset all the other timestamps in order to check that they fall in the right place. It is, of course, just possible. Give me 1 second here. There will be a moment of Twitchception here. Let me move that out of the way. Da, da, da. Oh, I can see there is YouTube chat. So I suspect that what's happened is that, as is often the case when we are playing live on the internet, the programs don't work. Because I can now see I've got a little YouTube chat in here. So this window here, this thing that you can see me waving around here, that is a thing called the Restream chat client that, in theory, combines chat from multiple platforms and puts it all into one place so everyone can see it. It appears it doesn't work, which is welcome to chat guideline. What? No. So hello YouTube. Let's put in a little thing in here. So we've got that's working on the YouTube, and yep, I don't see it. Ah, what fun, they said. What fun. Right. I will try my best and keep an eye on. So I've got YouTube chat popped out in its own window over here, and I can put that on kind of there. That's not going to work. All right, you won't be able to see the chat, but I will keep and try and keep an eye. If it's not working for you, it may not be working for other people. And the last thing I want is to upset anybody on the internet. You know, it's not why any of us is here. But I think I can get Twitch chat in one little standalone isolated window. So there we go. I've got that on there. I got that on there. Whee! That can go off over there, which is kind of nice. Ooh, it's working. Programs on the internet not working, never. So I think I can see both chats now, but there's very little correlation between what what you're saying and what you think you're saying and who can see what and all that kind of stuff. I think the answer, and Chris, you're going to hate me for this, is that I need to stop restreaming and I'm just going to go directly to Twitch from next week, because I suspect that Restream plugging into different chat APIs in real time is causing mischief. Also, I'm a Twitch affiliate now, and so I'm not supposed to be doing that, because they'll take away all of my pretend internet points, apparently, if I stream on YouTube as well. But anyway, right. So, console.WriteLine is slowing everything down by a factor of 1,000. I'm just going to throw in one extra little thing here, which is if ts mod 1000 equals 0, console.WriteLine, and I want to see how fast that is. 21 milliseconds. So that gives us, what I don't want to do is start something running and after 3 or 4 minutes I'm like, I have no idea if this is actually alive or not. I can't tell what's going on with it. But that looks like it's going to give us some interesting output there. So that's fine. That's nice. Console.read key, and then I'm going to just break out of the loop. So that'll end the application. Run that again. Boom, there we go. That works. Press a key to close. So take out the naughty input and put in the large input. And a little birdie on the internet told me that we possibly need in here to this thing here may need to be an int64. And this thing here may need to be an int64 because it is going to get chonky, is I believe what the cool kids are calling it. That's alright, that's alright. I think everything else will filter through. I think all the arithmetic things. Max is a nice optimization, but it doesn't bring real help when values get really big. You overran a long. Oh, no. No, don't, no. What's that going to do? Now, what size did they say this thing was going to get up to? Yeah, Excel uses 16-bit numbers by default, and 32 bits are long, or a big number in Excel, I think. Whereas this is .NET, so an int64 is one eternity later. Well, it's 2020. What else are you gonna do? Now the question is, do we have any expectation at all as to what the problem space that we are looking at here might be? Now we got a bunch of, hang on. So while this thing runs, I'm thinking about a potential optimization. Um, so yeah, Tanai says all longs are 64-bit longs. It'll be fine. So ulong is actually only twice as big because it doesn't have negatives. No, I don't need. I don't want to know what your answer is. I'm just thinking about some potential optimizations that we may be able to plug in here, because brute forcing this is gonna take a long, long time. Oh, look, Chris's comments are coming through on the stream again. The chat must have fixed itself. All right. So the algorithm is working here, but it's gonna take a really, really long time to come up with anything useful. So what can we do to okay, Eric's just posted his answer, and his answer is that long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like a 16-digit number. So getting there this way is going to take a very, very long time and not be entirely practical. So how do we break this down into something more interesting? So we are searching. Yeah, no, I think you're right. Okay, so the other thing that we know about this is that we know that the number we are looking for each of these prime numbers in our input, the number is gonna be some multiple of that prime plus a given index, right? So instead of looking at every single number and looking at every single one and seeing if any of them satisfy the conditions we want, perhaps there is another way we can do it, where we can say, all right, we've got so at the moment we're doing our TS equals max minus index of max. We got an iteration going on that way. But the potential solution, maybe we need to generate a different set of input candidates this way. CMHAR1 says it can be solved in millis, and I think CMHAR1 is probably correct. So what do we got? We got a bunch of numbers here. Let me switch back to the naughty input again to make things a little bit easier. So the potential optimizations that we've got in here are, so x is gonna be some number 7 times n plus 0, which is equal to 13 of some number m plus 1, which is equal to 2, 3, 4, 59 of some ln I'm going to use different numbers here. I'm going to say that equals 13c plus 1 equals 59. You either know what you need to use, or you probably need to just look it up. I don't want to look it up. I want to invent it from first principles. Because, hey, if everyone in the world is going to build their own CRM system, why shouldn't we reinvent this algorithm from first principles? Um, equals 59 times k plus 4 equal to 5, 6. So 31j plus 6 equals 19 HJKL plus 7. Uh, hmm. All right. So we want to solve some set of numbers such that 7i plus 0 is equal to 13j plus 1 equals 59k plus 4. So what we are looking for is a way of... So there's another brute force solution, which is where we just say for I equals 0 to 100, for j equals 0 to 100, for k equals 0 to 100, and we just run a massive kind of cascading loops inside loops inside loops and all the way down and go ridiculously deep on that front. So that'll be one way of doing it, but there must be a more elegant solution here. So now there's something ringing a bell about algorithms for solving kind of simultaneous linear. Yeah, I'm guessing. So, Chris, I'm guessing that the answer here is the name of an algorithm, or the name of a function. And if you know the name of the algorithm that you recognize from the pattern, you type it into Google and it says, here's the NPM package or whatever that does it. I think. And I don't want to know the name of the algorithm because that'd spoil the fun, because then it stops it being mathematics and it starts it being who knows the algorithms round in the pub quiz. So, let me think about this for a bit. So it's 7i plus 0 is 13j plus 1 is 59k plus 4. Calculating -1 so to compute without primes. What? I'm sure that comment was very helpful when it went into your end of the internet, but it's come out my end and I'm staring at it going, I'm not entirely sure what is going on with it. Oh yeah, we were going to do Zoom on this, weren't we? Yeah, I was actually out this afternoon. The reason it's a bit late is I met some friends up on the South Bank in London for a lunch and a socially distant beer. Nothing says hardcore like British people sitting outside in the rain drinking beer in the middle of December. But damn it, we are that hardcore. If I'd known I was going to be trying to implement prime number algorithms, I probably wouldn't have had a second beer with lunch. We're going to be joining you in Tier 3 on Wednesday, apparently, maybe, I hope not, but that's what all the indications are saying. Okay, so I'm going to think about this for about another 6 minutes, and if I haven't got any progress on it in 6 minutes, then I'm going to start punching in things on the internet and see if my Google foo is better than my maths foo. So 7i plus 0 equals 13j plus 1. So if we have some combination of prime numbers, what I'm wondering is there some sort of algorithm in here where so let's take that scenario there. 7i plus 0 equals 13j plus 1. That should yield a massive set of numbers. And then 59k plus 4. So um, hmm. $59. Right. I'm just going to poke around with this a little bit because I'm kind of curious. I don't know the answer and I can't really see a way in. So I'm going to do the mental equivalent of sort of walking around the outside of a house trying to work out which window you can probably crowbar the easiest. First of all, I wonder if I can create a static int find solution because I haven't got a better name for it yet. And this is going to take a dictionary of int constraints. And what it's going to do is, so at this point, the first input to this is going to be the find solution, new dictionary of int. Yep, that's fine. And the first element in this is going to be 7, 0. And the second element in this is then going to be, come on, 13, 1. So I want to find solution, return the lowest. Actually, we don't need a comment in here. This is never going to be published. Static and find solution 7, 0, 13, 1. So I'm gonna see what happens if I try and brute force this in a loop first. So no, because brute forcing it in a loop isn't going to work, because you don't know when to start incrementing the second loop, because there could be some number, some ridiculously large number that you'll not find if you give up on loop 1 and you start incrementing loop 2. So how do we find some number? And the multiples here are not the same. The multiples could be anything. The numbers we have are primes. So something times 7 times something is gonna, hang on. 7i is gonna be the actual solution we're looking for here. Let's just backtrack it. The actual solution we are looking for here is the lowest timestamp t such that, let me look at my conditions again. So we had the lowest timestamp t such that the timestamp modulo 7 is that, 13 is that, 59 is that. So some number, we're looking for some number t where t modulo that is that and t modulo that is that. But that also means that we are looking for the thing where I'm going to just grab that lot and drop this in over here because it might be helpful. What did I say? 1:15. I got 2 more minutes before I ask Google if it knows the answer, because I don't. So I'm going to drop that in there. That's fine. Yeah, that's nice. That's good. So dictionary int of 7 is 0. So is there any way, if we've only got 2 constraints, it's either got to be like, okay, brute forcing it isn't going to work, which either means there is some beautifully elegant way to yield a set of candidate solutions. Now, any such number t here, if t mod 7 equals 0 and t mod 13 equals 1, t has to be some multiple of 7, and I love the fact you're all literally giving up part of your Sunday to sit there on the internet watching me bang my head against prime number arithmetic and not make any progress. So, All right, what I'm thinking, my hunch here is saying there must be something to do with multiplication. The fact that the numbers are prime means they will have no products in common. You won't get any overlaps. Any combination of, um, powers of these primes is going to yield a unique solution. So it's something like if we got 7 and we got 13, the So 7 times 1, 7 times 2, 7 times, so 7, 7, 7 times table. So it's all the 7 times tables, but then it's the 13 times table plus 1s. 7 times table, 13 times table plus 1s. The 59 times table plus 4s. And somewhere these series of numbers are going to intersect, but we don't have an easy way of knowing in which direction to start a brute force enumeration. We like, when do we decide we're done with the 7 times table and it's time to look at 213s is whatever. Now that number also, the solution will also have the property that in this example, so x is a factor of 7. It'll have the property that x minus 1 is a multiple of 13. It'll have the property that x minus 4 is a modular property of a multiple of 59, but that doesn't help us because we already got that, and again, all it does is give us a way of looking at all the possible x's, x, 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 and hoping that maybe one of those x's is going to yield the right answer, and we have, as we've already ascertained, that's not going to help because there are too many numbers, and we do not have time to run through and look at all of them. So, all right, let's try something different. So, 7 times, we need a number that satisfies. Let's just look at these first two predicates here. It's got to be something that is 7, and 13 gives you something modulo 1. So 7 times some number, 7 times 14. So 13 plus 1 is gonna give us a bunch of 7 times 14. So what are the numbers that satisfy this first predicate here? So first of all, the number 7 fails because 7 mod 13 is not equal to 1. So then we look onto the next multiple of 7. So what do we got? That'll be 14. So does that work? So 14 14 modulo 7 equals 0, and 14 modulo 13 equals 1. That one would appear to be alright, but does it satisfy the third one? 14 modulo 59 that's no good. That does not help us at all. We actually need to jump up and look at numbers above 59, and in this instance we're looking for a number that when repeatedly a multiple of 59 that is 4 greater than a multiple of 7. See, this is one of those arithmetic things that I wouldn't be entirely surprised if it was just like you add all the numbers to their modulus offsets and multiply the sum, and that'll give you the answer, and it falls out by magic. And then someone goes and writes a thesis on why that's possible and why it works. Let me have a look. What was the solution to our first part of the thing here? I'm going to play around with this a little bit further. So we had our advent of code there is. So this one we're looking for 1068781, and that's out of that input. Okay. So, just out of curiosity and total, I wonder what the hell will happen if so what do we get if we do 7 times 13 times 59 times 31 times 19? Right, that is significantly larger than the solution we've got in there. So, hang on a second. Hang on a second. So could this be something to do with so that's all fine. Wait. Okay, so the number we need is smaller than the product of all the primes that constitute our input, which, okay, in this instance, the number we need is smaller than the product of the primes that constitutes our input. Now our indices here are 0, 1, 2, 3, 4. Adam says the algorithm you created worked but was too slow. Maybe there's something to fix that. Just loudly thinking. But what I'm now wondering is if there's some way of saying, so if we grab that set of inputs now and add them to their things, that gives us 7, 14, 59 plus 2 is 61, 31 plus 3 is 34, 19 plus 4 is 23. Yeah, multiplying all the primes together will be one cycle long. They all depart at the same time again after that time. So yeah, that'll be the point where all of the buses arrive at the same moment again. So we're looking for something in between the two. Now I'm wondering if there's something we can do here that will fall out of the prime factorization. So that 7 is prime. That 14 is a 7 times 2 factorization. 61 is prime. 34 is 17 times 2. And 23 is prime. And if we 7 times 2 times 17 times 23, no. I missed the 51. I missed the 61 in there. So this is 7 times 2 times 61. Clear that. 7 times 2 times 61 times 17 times, number lock is switched off, 7, thank you, times 2, thank you, times 61, thank you, times 17 times 23 equals what? $61 should be 63, right? No, because the input's 59. So what I was doing is I'm just saying, well, what if we add each of the prime number inputs to its offset? 1, 2, 3. Yeah, no, you're right. 1, 2, 3, 4. Those are the indexes. Yeah, thank you. 1, 2, 3, 4, 5, 6, 7. So then our numbers plus offsets, 59 plus 4 becomes 63. I'm just going to bump a bunch of tabs in here. Actually, I'm going to do this bit in Excel because Excel is going to give us a slightly easier way of just doing the kind of I don't know what I'm doing arithmetic that I'm doing right now, that I don't know what I'm doing with it. How do I split that on data text to columns? Thank you very much. Yeah, delimited on next, comma is fine. Thank you very much. Boom, done, finish. Okay. So indexes are gonna be, let me drop another column into the left here. So this is the bus ID, right? This is the index. We've got 0, 1, 2, 3. Pull those across. Sum of those is gonna be that plus that in each case. There we go. Plug those in there. Okay, so now what I'm trying to do is I'm exploring the idea that if we reduce these sums to their prime factorizations, and then we take each unique prime in the series of factorizations and we multiply those together, we might get something that yields a result. I cannot explain why I am doing this. It just seems like it might give us another way in. Like I said, this is mentally walking around the house looking for a window that hasn't been locked properly. So the factorizations we've got here is that one. 14 is 7 times 2, a 2. That one doesn't count because we're not interested in it. That one doesn't count. 63 is factorization of that is 21 and 3, except 21 is, so those are the unique prime factors of that. 37 is prime, and 26 is a 13 and a 2. 2 is already duplicated in there. So 7 is duplicated. So what we've got is 7 times 7. So 7 times 2 times 3 times 37 times 13 equals 7 times 2 times 3 times 37 times 13 equals not what we want, not even remotely. So yeah, that was not entirely what we were looking for there. But let's have another look. So that's 14 is a 7 and a 2. 63 is actually 3 times 7 times 3. So 3 squared. Yeah, 37 is already prime. 26 is 13 times 2. This is not necessarily yielding anything particularly useful. Right, I'm going to crunch some numbers backwards. I'm going to take the solution that they gave us, which is this one here. Okay, so there's that one there. So I'm going to drop in another column down here, and I'm going to say, well, what is our solution $m$3 divided by the ID? Okay. And then by the same token, oh man, I hate the way that Excel's. Okay, that yields nothing. That divided by the, actually that's the only whole number. The rest there's going to be this offset. There's going to be this error. You'd feel like you need the highest exponent of each factor to do what's MCM? So the highest exponent, minimum common multiple, yeah. So the highest exponent would be, yeah, maybe? I don't know. So it was also, I did the math and it also was not useful. So, we've got a 3 times 3 in, that's a 3 squared, so 3 squared there is 9, yeah, yeah, they're prime, yeah, the prime, not prime with the offsets. Hilarity ensues. This is difficult. This is seriously difficult. And if we'd brute forced it, it would probably have finished by now, right? But I'm wondering, so that number there is in Ruby, brute forcing was going to take 4 days, hence why I came to the Twitch. How do you know how long it's going to take to brute force? If you don't know the answer, because if you know the answer, then you can just start there. And if you don't know the answer, you have no idea how long the algorithm is going to take to run. Now, those of you who have seen this, am I correct in thinking, yeah. Am I correct in thinking, Max helped a bit, what if we did better? Brute force had better input. The worst case is the product of all the primes. Actually, that's true. What is the product of all these primes? On my big fat boy input that I had over here. Let's have a look at... Because that's not gonna be that big a number, he says, optimistically. I'm going to see what the product of those numbers is. Static read-only static find solution. That's fine. We're not interested in doing anything with that. Not going to help us right now. That's redundant. That's gonna not work. And so I want to say on here, static read-only and input. So our options are we try and reduce the size of the input space, or we try and work out a way of solving it in less time by running it faster. Either we have to search less numbers, or we need to search numbers in a shorter amount of time. So input start console.write. I don't think there is a product. There is a sum, but there isn't a product. That is the product of all the primes that I've got there. No, that's fine. Okay. So anything that is just you clearly watching me trying to like do something that's just a question of working out how to ask the right question, then yeah, that's cool. So the product of all the primes in my input is that. Yeah. And there's a way of not having to search at all, but calculate. Yeah, so the two options we got. Adam is in the chat saying, you know, the brute force had better input. Max would help. What if we did better? Chris is saying, what if there's a way of not having to search but calculate it instead? So we've got the be more elegant or be more powerful. And the be more powerful is like, can we search fewer things, or can we search the things that we've got faster? Now, one option would be to go onto Azure and just fire up a massive 32-core processor and throw horsepower at it for a couple of minutes, which might yield some interesting outputs at the end of the process. But I'm still convinced that there must be a way of doing this that is elegant. There must be it feels like there is a solution that will emerge from the mathematics that does not need you to just search every single number in order in brute force. So let me go back and have a look in Excel. So we're looking for this number here. And the properties that we know about this number here is that this number here is it is a multiple of 7. That number there minus 1 is a multiple of 13. That minus 1 equals M3 minus 1 divided by 13. No, okay. That number there is, hang on, what? That number there is M3 minus 1, so that's fine. Ooh, hang on. Let me throw in another. So the prime factorization, yeah, okay, right. So in here, I want to put our $M$3 minus the index of that cell. That's fine. I'm going to drop that in everywhere here. And then I want to say in here, what is that divided by that? Why am I getting a fractional result out of that? Why am I getting a fractional result out of that? Let me double check the inputs that we're working with here. So we've got the 7, 13, yeah. Bus 13 departs 1 minute after T. So hang on, bus 13 departs 1 minute after T. So that is timestamp T here is that. So that one, no, it should be plus. Equals that one divided by that one. Yeah, okay. So right. So what I've done here is let me scrub these out because they don't matter. We are still ignoring all of the requirements on the x's, aren't we? That's fine. So so what is interesting now about this set of numbers? Equals that one divided by that one. Nope, that gives us nothing. 18115 is so yeah, these are the respective powers or the respective multiples of all the different effectively, yeah, think of it this way. The moment that satisfies the problem is when bus number 7 comes round for the 152,683rd time, and then 1 minute later bus number 13 comes round for the 82,214th time, and then 4 minutes later bus number 59 comes round for the 18,115th time, and then 2 minutes after that, bus 31 comes round for the 34,477th time, and then bus number 19 comes round for the 56,252nd time. Which, what if? So now I'm wondering whether there is some subtracting the index from the ID might give us something. No, it won't. That sum column and that sum row there is not yielding any help for us. So that's the time. Yep. And that is the iteration of that particular bus. That's how often it's come around there. So what I need to do, if I can work out the iteration of the buses, I can, yeah, but that's not going to help. Oh, hang on. There is some sort of, we're looking for a range of numbers. And we are looking here for a range of numbers. Yeah. What if you could better in the result of multiply better and better values? So, okay, the thing that I've just kind of realized here is that the right. Hang on, have a look at this a second. So, because the numbers we're looking for are going to be within a particular range, right? So there is no point, for example, at considering bus 31 on its first iteration and bus 19 on its 120th iteration, because those aren't even in the same ballpark. What we can do is we can say, well, the multiples that we apply to each of these numbers have to yield something that is within a particular range, you know? And so if you look at the iterations that we've got in here, if I do a quick bit of multiplication on here, so that one multiplied by that one, that's the numbers that we've already got. But if I do that multiplied by 34 over 13, 56 over 19, how do you work out if they fall in that range without calculating it all anyway? Well, what you can do, okay, so what I'm thinking you can do is, for example, say, all right, let's say we are looking at iteration number 1 of bus ID number. So, okay, so iteration number 1, this means that it is going to come around after 7 minutes. Is there any multiple of 13 that would put it within, yeah, maybe, nah. There is no multiple of 13 which will put it within range of 7 minutes. There is no multiple of 59 that will put it within range of 7 minutes. There is no multiple of 31 that will put it within our acceptable range of 7 minutes. There is no multiple of 19 that will put it in range in range of 7 minutes. So we can ignore that. So we only want to consider the multiples of 7 that give us something kind of, yeah, broadly within the ballpark of what we're looking for. Adam's comment about, remember, max helped because the result is a multiplier, but what if you could have better and better value? The result, so you're saying as we get bigger, we skip, there's some way of saying, instead of having to search every single possible multiple of this, we can refine the iteration so that we are casting the net wider as we go along. Today's is kind of fun, you know. So right, take a number 7. Let's assume, say, 7 times 200 equals, indulge me here a second, equals that times that. So 7 times that number gives us 14,000. Now we are interested in 13. Seven times 200 gives us 1400. So that's our timestamp. That bus comes at 14. So then that one is going to be at 1401. That one there is going to be 1404, 1406, 1407. Now, if there is any multiple of 13 that will yield, so let's say in there, that is going to be that one divided by that one. Nope, that's not going to work. I mean, this is potentially going to give us a much lighter kind of brute force approach, because if we go back over to maybe so the way I'm already doing it is the optimization is falling out of the way link optimizes the select statements. So we got this thing here, select bus ID, and because that's an input.select, it's going to go checks.all, which means as soon as one of these things returns false, it's going to yield. So that's not gonna work. I'm just trying to kind of get a reasonable picture in my head of the way the arithmetic in this thing fits together. So, and I'm just kind of, yeah, there must be a better way. So at the moment we're just iterating on the max. So we're like, all right, well, let's start with the first potential ID we've got is we've got a 59 in there. So if you knew how often the first two buses happened to arrive at a needed time, how could it help with finding a solution to 3 buses? Yeah, so all right, if we can find a set of solutions that work for buses 7 and 13, and then search that set of solutions and find the ones that work for 59, and then search that set of solutions and find the ones that work for 31, and then search that set of solutions and find the ones that work for 19. So, hang on. Okay, so this might be interesting. Okay, so enumeral.range from 0 to int32.maxValue. So we're going to int64.maxValue because let's bring the big dog. Then we want to say from that, yeah. Why is that complaining? Can we not do that? Is that not allowed? All right, I'm going to cheat. I'm going to use a uint because I know they start at 0. But I think the enumerable.range. So yeah, if we solve the problem with the 2 biggest buses, work at when they appear. Yeah. Well, no, because this is the whole point. Because if you can solve it for the 2 biggest buses and use those to find the 3rd biggest bus, and then use those to find the 4th biggest bus, and then use those, I can feel that the shape of the solution sort of tickling at the back of my brain somewhere here. So the difficulty is in saying, at what point do you so what we need is to let's so let me. I'm just going to play around with something here. This isn't going to make sense yet, but I think it might help me kind of get some of it out of my brain and onto the screen, and then the bit that's left in my brain I can chew over some more. So I'm going to say var first pass equals so at this point we can we got our set of inputs here, right? So input dot yeah, that's exactly it, I think. So we got input dot and what's input? Input is a dictionary of no, input is So first of all, I want to say input dot select all the numbers. So hang on, right? I mean, this may not work, but I'm going to try it anyway. So I'm going to say enumerable dot range of 0 to. Now I know that we're going to get some stupid chunky numbers out of the far end of it, and then I want to select from that all of the multiples of. I think we can just do this in order. Input equals new that, new that, new that, new that. So let me just do a var things equals input dot select bus ID input dot to dictionary. I hope there is an int selector on this thing. No, there isn't. This is all right. Input dot select bus ID index. JavaScript can do this. Bus ID index goes to new bus ID equals bus ID index equals index. I wonder if it'll let me do this. Okay, well this is a dot to dictionary tuple goes to tuple dot Elsinore says I don't have Fire code installed on Real Visual Studio at the moment. So that we need a dictionary. Tuple goes to tuple dot bus ID, and the dictionary value is going to be tuple goes to tuple dot index. Okay. Have a look at the various places where the 7 and 13 buses arrive at their respective correct times. First 10 values of that should be enough. Alright, so let's let me crunch that then. So we've got this fun little thing in here. I'm going to comment that lot out just for a second while we run this thing through. And I am going to say, take my input, and I am just going to chop that out. That's Dan's solution for all my integers added together. Drop the input back in and just say 7 and 13. That's fine. That can come out for now. We'll come back to that in a second. Input equals 7 and 13. Main stopwatch. That's fine. That's fine. Run that one. But now in every single situation, I want to say, I'm going to take out that break, and I'm going to print that. So that, my friends, would appear to be an infinite loop that is never doing anything. What is wrong with solves part 2? Yep, that's fine, that's fine, that's fine. TS plus index mod bus ID equals 0. That should be fine. Let me start my long TS equals 0. That's fine. And then TS plus plus, that's fine. $77, $168, $259, $350, $441, $532, $623, $714, $805. Boom, copy that lot. Text pad, new, paste, F9, sort that, grab that, back it up. Sort that again, numerical order. Okay, copy that, drop that into Excel, and give me the difference between iterative elements in this series equals that minus that. That's fine. All right, what is the relationship between 713 and 91? It is multiple. Yeah. 7 times 13 equals 91. But if we now factor in, let me have a look, factor in 59 instead into the solution that we have there. I'm going to break out of that. What's the next input I got on mine? 0.059. Yep. Hang on, let me stop that. I want to take out the winner chicken dinner. We don't need that. We don't need that. Console.writeline that one. That should be fine. Alright, and grab that lot, and copy that lot, and drop that lot in over here, and now just do exactly the same thing there. 5369, and 5369 equals 7 times 13 times 59. So, no way. Okay. How do we know 350? How do we know that's where we start? Because okay, so in this instance, so this is interesting. This is really interesting. But the number that we want is that's what we're looking for. We're looking for 350, and we've just found a way that if we've got to 350, you can then very, very quickly find all of the other valid solutions if you know the lowest number you can start from. Starting with the biggest bus first, it will be quicker. So the yeah. So okay. So the answer. Okay. So those are all the numbers that satisfy it for. Ha. What I've missed here. All right. Check this out. Let me visualize this in a way that's going to help us figure the thing out. So I'm getting a kind of Eratosthenes sieve type prickling going on here. So let's have a look. So if we've only got 2 buses, stop that and run that again. All right. Right. There we go. Whole bunch of buses, which of course I probably can't. Oh, I can copy them. Windows got good, didn't it? It got really good, and I've liked it since 3.1. So let me stick a new sheet on the spreadsheet here. So those are all the solutions to 2 buses, And then the valid solutions that we identified for 3 buses are Excel, why you no use clipboard like normal application? So 350 is that one there? Nope, 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 no, 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 no. But if 5719 is in this list, yes. Beautiful. Okay. So, what we can do is we can solve it for a certain number. So if we solve it for 3 buses, and then find the increment between, because then I'm guessing when we plug in 4 buses, our first answer is going to be down in the 10,000 somewhere. So let me just do that for my own curiosity. 13, 0, 0, 59, 0, 31. Run. Boom. Yeah. 70,000. 236,000. All right. So you can start now at 77 and increment by 91 to find for 3 buses. Yep. And then we can start at 350 and increment by whatever that was to solve for 4 buses. So, right. Now the question is, do I need to write a program that is going to figure all this stuff out? Or do I just repeatedly, because I could run this manually and get the increment for 2 buses, and I could feed that back into the program and get the increment for 3 buses, and I could feed that back into the program, get the increment for 4 buses, and eventually I'll get at the other end the increment for all the buses. I'm not going to do it in Excel. No. Excel is fun for playing around with the shapes of numbers and things, but I'm not. I've also just noticed I got both chat systems running side by side now. All right. So what we want to do then is, yeah, it does sound like a huge pain. Let's do it this way. So let's do a so that's our input there. We need to keep that, right? That's what's actually being crunched into this thing. Now, yep, we're going to go program. We're going to go for a program. We're going to go for a program. So what I want to do here is I want to write a function which is going to be called a, so find interval, and this is going to take the inputs, and it is going to take a int limit. How many are we going to look at in this instance? So now then, our so let's start off with the case where limit is equal to 2. What we are going to do is we are going to say var checks equals input.select bus ID goes to that. So and we're going to say so we want to plug in all of the possible var I equals 0, I is less than int32.max value I++. I think, not sure, but I think this might work. Return I plus index equals bus ID. So that's going to give us our set of solutions for a given number. Let me just check. Up here we were doing TS++ in every case, right? But that's an enumeration, so that's lazily evaluated. So that's kind of fine. So input.select where all of those equal so var solutions equals, people were just putting equations into Wolfram and solving it that way. Nah, where's the fun in that? Enumerable.range from 0 to int32.max value dot select for any given integer I, we want a number such that input.select that.i.all. B goes to B. So find the elements that satisfy this set of predicates. That can come out. We don't need it. And what we are interested in is solutions.var first equals solutions.first. Var second equals solutions dot skip. Is there a dot second in link? Actually, we just do it in a link. For each var I in solutions. This is weird. I've never had a scenario where I need to get exactly two things off the beginning of an enumeration before. So I in solutions, we want to grab the. You know what? This is unpleasant, but it's probably going to be okay for what we need. Var first equals solutions dot first. Var second equals solutions dot second. Dot skip. 1 dot first. Yep. All right. That's grubby, but it'll do. What is that? What? No, that's fine. I don't want to enumerate to array or to list because I only need the first two in the list here. So let's. You know what? This is I'm trying to be a little too clever here. For var I long I equals naught, I is less than int64.max value I++. So we're going to say for all of the possible 64-bit numbers, if input.select that, so at this point it's actually if limit there is actually gonna be if input.take limit is the thing that we need. So that's gonna go grab that number of inputs, and if that gives back an answer we can work with, that's fine. So that's gonna say input take limit, that's going to give that, that's going to spit that back. Elzenor BW says their index is 0 and 1. For statement instead of a fancy iterator, long first equals 0. Long second equals 0, or actually long initial and long interval will do nicely. I wish those words were the same length. Interval 0, so that one's there, that one's there. If input.take limit, if that does that thing. So if initial equals 0, initial equals I. So if we haven't seen any yet, capture the first one. Otherwise, interval equals I and break out of the loop. That's fine. And this is going to return a int find interval. That's nice. That's fine. There's the input. There's the limit. And this is going to return initial and interval in a tuple, which is fun and kind of nice. And that's complaining because long, not int. Okay. Might work. Might work, might not work. Let me just chop out a chunk of code here we probably don't need. That can come. We can reinstate all that lot later. That's fine. First, second. So root. Give me just delta equals find interval input dot take. No, it's just input, isn't it? Because I specified a limit parameter elsewhere. To what does that want to do? Name root does not exist. Long root long delta equals that. Yep. Use var. Yep, that's fine. Console.log root. Console.writeLine delta. If this is right, it's going to replicate those numeric statements that we just kind of plumbed around by digging around in Excel. Console.readKey false, because old habits die hard. Let's see what we get out of that. Boom. 19 and 38. So 19 is our seed value, 38 is our second value. If I bump that up to 3 now, 19 and 38 is not what we wanted. Actually, no, because those ones don't matter, do they? 19 and 38. And if we bump that up to 5... Oh, it's on the real input now. Hang on. We want this on the donkey input, not the real input. Yeah, so 1, 2, 3, 4, 5 should give us something interesting. So let's, first two gives us 7,768. Yep, that's fine. Give it 3. We're expecting that 5,000, what was it? 1, 2, 3, 4, 5 should give us a 4-digit number with a 2 in it somewhere, if memory serves. 5719. That's fair enough. And we actually want interval equals I minus initial, because that's the thing we need, isn't it? 5369, which I think is... Yep, that's the interval that came out of our spreadsheet system. So we now have a thing that will give us... And this is where if limit equals yeah. So no, all I need to do now is feed this thing back into itself somehow. Need to wire the output back into the input, because this thing is a so that one is gonna be, that's 0, that's 1. So that is gonna start with what I'm wondering is, can we do like a base case scenario that says if the limit here is 1, then set the initial to 0, the interval to 1. Otherwise, set it to... Yeah, I plus equals interval. But what I'm wondering, let me just push this. I'm just going to git commit this because I'm about to do something I may not be able to remember how to undo. Let me grab a terminal window here. cd / cd projects, cd github, cd advent of code, git add dot git commit -m. About to do something unwise with recursion. Right, there, we can get that back if we need it. So what I'm thinking is, so the way to find 7 buses is to get the interval for 6 buses and use that. And the way to get 6 buses is to get the 5 bus one, 4 bus one, 4 bus one. So if the if limit equals 2, then so long interval equals 1. So if the limit is greater than 2, initial interval equals find interval input limit -1. And then for long I equals initial, I is less than that, I plus equals interval. So that will run it on 2 buses. It'll go for 0, it'll go for 1, and it'll limit the input to that thing. Let me see what this does. Your last limit as parameters, it makes sense to pass initial and interval as well. Yeah, hang on. Recursion. Recursion. No, that's not quite adding up properly. Backtrack that. Okay. So we got a function that will take an input and a limit, and it will give us the interval and the initial. So let's start by passing those in as parameters. So long initial, long interval int input, int limit. That comes out. We don't need that. Initial that is that plus equals interval. That's fine. So var root delta equals find. Okay, I think we can now just loop on this thing. I think, maybe, possibly. So we want to start off with 0 and 1, and input and 5. Console.log both of them. 350, 5369. Okay. But now if I go for 7 on that, this should take considerable time. 70147 1.6439. And the solution that we actually need in here now is that and then we want to plug this in for var ts equals root. Ts is for var ts equals root while ts or while true, big fat loop here. If solves part 2 ts return or console.writeline ts. Style bonuses. There are style bonuses in Advent of Code. That's fine. If does that, and then ts plus equals delta. Okay, and bail out on that. So this will give us a... oh, that's nice. I did not know you could do that. That's very shiny. Input and limit, and limit on here should by so this one will work, I think. No. Oh, of course, yeah, that's finding all the solutions. (70147). No, that is not a valid solution. Why does it think that is a valid solution? Yeah, so that should be fine. That's still working. 0, 1, 2, 3, 4, 5, 6. What's the result we're expecting from the example input? So 730, and that ends with a 19. I've taken the 19 off the end of the example input. I don't know why I did that. And this one is looking for 1068781. Yep. 1068781. Right, that works. So, what we need to do now is um, 5, 6. Yeah. So that's fine. So first thing I'm gonna do is just say right. So root delta equals find interval 0, 1 input. Let me see what I get out of a 2 on that. So there's that. And then console.log console.writeline root delta limit close that out. Var limit equals 2. That's fine. Plug a limit in there. Run that lot. 7791 limit of 2. Okay, that's looking rather nice. So what I think I want to do now is I want to say var long initial equals 0, long interval equals 1, while limit is less than input dot length. Initial interval equals find interval initial interval input limit. I'll do a little console write on each one of those. And I need to say limit plus plus. What'd I do? Oh, nice work, Chris. Root 77. No, what? No, come on. Be nice. Why is that blowing up that hard that quickly? Initial interval, return initial interval. Remember to skip zeros. It shouldn't matter. No, they should just... So what do I get out of that? Yeah. Yeah, that's fine. What do I get if I plug in limit 5 here? 7791, limit is 2. If I make the limit on here 5, 350, 369, limit is 5. That's right. If I make the limit on here 6 and run that, that's 5369. If I make the limit on here 7 and run that again, yeah, this is working. Just let me see what I get if I make that 9. Yeah, at that point it blows up, it brute forces completely because it's like it's now using the correct answer as the root for the iteration. So why is my little thing, if I start the limit here at 2, I need to plus it. I keep forgetting to do that. Limit plus plus. Right, what am I doing wrong? Why does this thing work when I increment the limit manually, but then it doesn't work when I feed the algorithm back into itself? It's the zeros. It doesn't increment on the zeros. That's fine. All right. That's nice. So, uh, but if I now say, what do we get if we say initial equals foo, interval equals bar, run the whole thing again. Nothing. It blows up. It chokes. What the dickens is going on here? You're always incrementing by at least one. Incrementing what? I'm just going to try something really weird. Value plus equals interval. Yeah. Um, where's value? Elsinore, give me a line number. Hey, Anatoly. Здравствуйте. So, right. I'm just going to try something because I'm worried that there's something weird going on with the assignments that are going on inside this loop here. So, I'm going to comment that like that, and I'm going to say var initial one, so a1 b1 equals find interval of, and I'm going to start with 0. Interval is 1. Input is that. Yeah, I'm good. I'm good. Всем хорошо, as they say. So there's that one. And then I'm going to say var a2 b2 equals find interval of a1 b1, and then I'm going to say the same thing for a3 b3 equals find interval of that, and 4. Just because I'm a little kind of confused as to why it's things are going to 0 and then blowing up. I have no idea why that's happening. So breakpoint on that one there. Okay, boom. Find interval 0, 1. That is going to yield A1 is 77. That's 91. Okay, that's cool. That should be 77, 91. Yeah, okay, that's weird. That's now 0. Why is that 0? Because could be because those are zeros. Let me throw in another case on the end here. Yeah. But why? Let me see what we get out of this. You know, after Advent of Code is done, I may keep doing the streaming thing, but I'm probably going to stream things I know how to do. I think that might be a more entertaining experience for all kinds of things. Okay, so that's interesting. So the interval, if I pass in that there, why is that blowing up and breaking out? Um, because nothing in here should be setting that interval to 0. Uh, maybe there's just a really wonky edge case in there. No, it's just 77.90. Hang on. 2, 3, 4, 5, 6, 7. Run it again. 77 and 91. That's fine, that's fine, that's fine. 77, 273. 77, 273. Now the bloody interval, the initial value is refusing to behave. Yeah. Hang on. There's this guard clause in here, which I plugged in the first. Ah. Oh. Var found it yet equals false. So actually, this would be var first one found equals false. So if first one found still looking equals true. So if still looking, my things only work if we initialize those values at 0, which doesn't work when you. So if we are still looking, then the initial equals I, and still looking equals false. Otherwise, set that and bail out. If you made an input list of pairs value index is not to play, well, it's not so much the 0 case. It's just that I need to return the first and the second element in the, so when I find one, I need to grab it, and then I need to keep looping until I find another one. And this one here, so the reason I haven't filtered them out is because I'm using select, which takes the bus and the index. If I filter them out, it modifies the indexes, so I'd have to turn it into a dictionary to be able to do that. Let's see what we get out of this now. So 77.91, 77.91, 77, 355, 369, 355, 369, 70,000, 166,439. Okay, boom, run that thing through. Where is my output window? 1068781. All right, so now I've fixed the bugs in that algorithm there. Let's bail that out of what we're doing. I should be able to uncomment that lot, drop this lot back into what we are doing here. Run that. Okay, so foobar foo 77, that's fine. That's yeah. So interval now, we're jumping up in increments of 166,000. We got a result. Okay, that's cool. So Part 1, Excel, 15 minutes, nice and easy. Part 2, prime number theory, 2.5 hours. Goodness, 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 goodness. Right, let's run that and see what we got. Okay. So I'm just gonna stick a oops, did I win? I don't know. I closed the window. Uh, let's run that again. Sweet. Look at that. There we go. And let's just see total runtime for that one. I'm going to take out that, clean this up a bit. That can come out, that can come out, that can come out. We don't need those. That can come out, that can go in there, so clean that up. We don't need any of those. That's fine. sw.start, console write line, software stopwatch.stop, console.write line, solved in sw.elapsed milliseconds, boom, run it, ship it, 30 milliseconds. Could be faster. The Chinese remainder theorem. That's good to know. Right, okay. Anyway, right. Thank you for watching, gang. That was 2 hours and 43 minutes of my, all of our lives that we'll never get back, so I hope you enjoyed it as much as I did. Although I was actually supposed to be doing some real paid work tonight, so I'm going to meet up banging my head against Azure database deployment configurations for something I said I'd have finished on Monday morning. Thank you for tuning in, gang. That was challenging, but we got there in the end. Git commit -m solved it in 30 milliseconds using recursion and prime stuff. Push. All right, and I think that probably, yeah, 30 milliseconds. Nice. Cool. Right. It's that time again when we go twitch.tv and we see who's streaming at 8:45 on a Sunday evening. And we're going to go and raid them and drop in on them and see what it is that they're up to. Who do we have who's online at the moment? Anyone want to suggest somebody? So most of the Advent of Code folks we've been following are not currently online, but I Develop Things is on. Oh, I'm not sure what they're working on. Let me go to the front and see who's live on this thing right now. Who's live? Dum, 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 dum. Nope, that's not up. That's not up. That's not up. That's not. I really need to get my Twitch foo. Who's on science and technology? The Frank Show is doing something with science and tech. Lana Lux. Who is Samelios? Do I know Samelios? Algorithm Archive all the way. Yeah, let's do that one. Sim-U-E-I-O-S. There we go. All right, gang. Let's rock and roll. You're going to read Samelios. I'll see you all tomorrow for day 14, whatever that has in store. Thanks for tuning in. Take it easy.